So hello everyone, in this video we'll be solving another LeetCode problem, and the problem name is design auction system. So you are asked to design an auction system that manages bids from multiple users in real time. So each bid is associated with a user ID, an item ID and a particular bid amount. Now you want to implement this auction system class, in which first is the auction system which initializes this auction system object. Then there is one function of add bid which takes user ID, item ID and that particular bid amount, which adds a new bid for a particular item ID by this user ID with this bid amount. Now if the same user ID already has a bid on this particular item ID, then you can replace the previous bid amount with this new bid amount. The next function is the update bid. So update bid also takes this user ID, item ID and this new amount as the parameters. Now it updates the existing bid of user or this user ID for this item ID with this new amount, and it is guaranteed that this bid will always exist. So if they are saying you need to update the bid for a particular item ID with some user ID, then it is not that this will never exist. This will exist, that is they have made sure that it is guaranteed. Now if you look at this add bid function and update bid function, these are actually same only. We can just write the same code in the update part also, because in the add bid part also we are checking if the user is already exists, then you need to replace it with the previous item, and that is what actually we are doing in this update part. So we can write the similar code for both add part and update part, or if you want you can just call the same function in the update part for this add bid part also. So yeah, anyways, that we will see in the code also. The next function is the remove bid. So it takes user ID and item IDs, which removes the bid of user ID for this particular item ID, and it is also saying that it is guaranteed that this bid will always exist. So if they are saying that you need to remove, it is guaranteed that that particular bid will exist, then only we are saying to remove it. Now in the end, the last function is the get highest bidder, which takes item ID as the parameter. So this returns the user ID of the highest bidder for this particular item ID, and if there are multiple users have the same highest bid amount, then you need to return the user with the highest user ID. So let's say the highest bid amount is let's say 400, and there are two users have the same bid amount, user ID 5 and user ID 4. So in this case you need to return 5 because it is its user ID is higher than this user ID 4. And if no bid exists for this particular item, you need to return -1. So yeah, this is what the question is saying. So question is pretty much simple. We just need to implement these functions, and this is a design kind of problem. Actually it is a design problem only. So in this kind of problem we only need to implement the things which are being told to us. Now the important thing here in these kinds of design problem is that how efficiently you implement it. And to implement this efficiently, we tend to use data structures which will help us to get some particular data in some constant time or lesser time than the usual brute force manner. So we use some data structures in order to process each and everything over these functions. So generally in these kinds of questions we tend to use map and priority queues in most of the cases. So in this case also we'll be using map. Now why we are using map, you can just see. If you see this add bid, update bid, remove bid, so you can see everything is evolving around user ID, item ID and this particular bid amount. Now for this particular item there is one bid created by this user which has the bid amount as this bid. So you can see, like, obviously there is mapping with item to user and user with this particular bid. So we can create a map which can take item ID as the first key and user ID as the second key, and for this item this user ID has what bid that will be storing inside the map. So this will be the map that we will be creating. So let me just show you. So we'll be using the unordered map because indirectly we just need to do the search operation. We do not have anything to do with this ordering of the element until and unless we are implementing the last function, that is the get highest bidder. So we will also make sure that how will we handle that case without this unordered map. But yeah, for now we will be creating an unordered map which will be taking int, and the other key will be again an unordered map which takes again integer comma integer. So we will name this MP. Now this integer is nothing but item ID, which will be the first key. This integer will be the user ID, which will be the second key. And for this item, for this user, what is the bid amount? So this integer will tell us the bid amount. So whenever we want to add any bid, we want to update any bid, or we want to remove any bid, so what we can do, we can just search for this particular item ID with this user ID, and we can just change whatever value we need to do in case of update, and similar thing will happen in case of add. And in remove we can just make it 0, or we can just erase this value from our map. So this is one thing that we need to do. Now there is one problem, that how will we get this highest bidder? Because if you see, for every item we have user, and for that we have bid amount. Now to get the highest bidder, that means we need to get this highest bid value. That means for every user we need to compare what is the bid value, and then we will get to know what is the highest bid value. And then we need to iterate over this map again to get which user has the highest bid value. Or we can also do this side by side, but main point of here saying is that you need to traverse to each and every users at least one in order to get this highest bid amount. And in the worst case, to iterate over each and every user, it will take O of n time, which is not suitable. So how we can do this thing, how we can tackle this scenario? So we have one map till now. So what we can do, we can create another map which will have set inside it. So what we can do, we can create unordered map which will have the integer, which is same the item ID, and the second value will be nothing but set, which contains pair of elements int comma int, and this will be giving us the bid, to get bids. Now what will happen, this is the item ID, this first integer is the bid amount, and this integer is the user ID. Now set will make sure that we have the values in the sorted order. So for this item ID, we will always have the smallest bid on top and smallest user ID on top, because we are storing in the set. So for each and every item ID, we will have the smallest bid value first and smallest user ID first. So we can get the set for a particular item ID, we can get the last value, because that last value will give us what? The highest bid value, along with that highest user ID if there is a tie. So highest user ID. So with the help of these two maps, we will be able to solve this problem. Now there is one more thing to make sure that anything that we are updating here in this map, whether we are adding any bid, whether we are removing any bid, or we are updating any bid, we need to make sure that we update in this second map also, because these two are linked together. So we also need to make sure any change we do in this first map, we need to do changes in the second map also. So yeah, this problem is actually solved now. We just need to make sure of what data structures and how will we implement those data structures in most optimal manner. So this is the basic part of the problem. We'll be using two unordered maps. One will keep track of item ID, user ID with their bid amount, and the other will keep track of the highest bid. So item ID, bid amount, and the user ID stored in set. So this is how we'll be solving this problem. Now this problem is just implementation based, so we can just see the code now and understand in more better way. So this is the code. So let me just zoom in a little bit. So yes. So first I have created this MP unordered map, which is again the item ID. This is user ID, and this is bid amount. Then I have created the another unordered map, which is get bids, which will be giving us the which will be taking the item ID. This will be the bid amount, and the last one will be the user ID. So first function is the add bid. So first of all, when we are adding a bid, we need to make sure if there is some already bid made by this user ID for this particular item or not. So we are getting that last bid, and then we are replacing that last bid with this current bid amount. Now if that last bid exists, that means we need to update in this get bids also, because we have seen that if whatever change we do inside this map, we need to make sure that we do the same implementation in this map also, because these are two maps which are linked together, which are showing the same data. So we need to update in this map also. For this particular item ID, first remove this particular bid which we had previously, and then insert this new bid with this bid amount for this user ID. So this is the add function. Now this is the update function. The update function is same as the add function. We have already seen why add and update can be same, because in the add also we can have the scenario that if a user already exists for this particular item ID, so we need to update or replace the value. So that is what actually update is also doing. So we can write the same code here in update also. First get the last bid, replace it with the new amount. If the last bid is there, in this case obviously it will be there, so remove it from the get bids part and insert the new bid amount in the get bids map. So same as the add bid function. So this update bid is exactly same as the add bid function. Now we need to write the remove bid function. So remove bid function, just take the bid amount and just make sure that you make the current value inside the map equal to 0 and remove it from the get bid. Why remove it from the get bid? Obviously we need to make these two maps in sync to each other. So if we are making any changes or we are removing anything from the map 1, we need to remove it from the get bid also, because this bid is now never exist. So we are removing it from the map 1 and we are also erasing it from the get bids map. Then we have the last function, that is get highest bidder. Now to get the highest bidder, we need to make sure if there is a bid exist or not. If this bid exists, then only we can get the highest bidder, otherwise we will return -1. So for this particular item ID, if there is any bid exists, then only find the highest bidder, otherwise return -1. And if the highest bidder exists, then how will we get that highest bidder? Just take the last value, because we have seen that set contains pair of int comma int. So this will make sure that it is sorted in the ascending order. Now to get the highest value, we need to take the last value. So this will give us the last value. And what it will give us the last value? It will give us a pair. So it will give us pair of int comma int. And how and what this pair will contain? The first value will contain the bid and the second value will contain the user. Now we need to get the user. So we need to get the second element of this pair. So what is this pair? This pair is bid underscore user. That means first value is containing bid, second value is containing user. So we need to return the second value. So from the bid underscore user, whatever is the second value, just return that. That will be our highest bidder. So yeah, this is how we'll be solving this particular problem. So I hope you understand this solution. Thank you for watching.